We have one more topic in Chapter 18, and that is molarity. Molarity measures the concentration. You can talk about something being concentrated, something about being dilute. If you had concentrated orange juice, that's the solid orange juice in the freezer, and then you add water, which means you dilute it. But that doesn't really tell you how much is in there, because maybe somebody thinks that's too strong and they add even more water than the instructions say, and they dilute it even more. So which one was dilute, the first one or the second one? So we use molarity. Molarity is defined as the number of moles of solute dissolved in 1 liter of solution. Number of moles of solute dissolved in 1 liter of solution. And again, that's the total amount of solution. It's kind of like when we make Kool-Aid. You don't fill it up to the 2-quart mark and then add your cup of sugar, because then it goes over the line. So it's the total amount. You add your solute first, and then you add your water, so that the total space that it takes up is 1 liter. So remember, that's the total volume. This can be written in a mathematical equation. Molarity is equal to moles over liters. Okay? Remember, this is moles of solute, and this is total liters of solution. You'll have 3 different types of problems that you're going to work out. So my first problem that I'm going to give you, it's very simple. It says you have 0.5 moles of sodium chloride, and it's dissolved to make 0.05 liters of solution. What is the concentration? What is the molarity? So you take your 0.5 moles and put it there. So you have 0.5 moles. And then you're going to divide it by liters of solution, which is 0.05 liters. So hopefully you all have your calculators at home. If not, get out those phones. And, whoops, did I do that right? 0.5 divided by 0.05. All right, gives me 10 moles per liter. Now, most of the time, you're not going to see moles per liter. They're going to write it as 10 and a capital M. And we read that as a 10 molar solution. Capital M can replace the moles per liter. So that's one type of problem that you will have. Now, when I make your solutions, I have no way to measure out moles. So I'm always given grams, or I have to calculate grams. So another type of problem would be when they give me grams. So we're going to just change this slightly and say we have, let's make this grams. 0.5 grams of NaCl. And let's say we're going to dissolve it to make another 0.05 liter solution. I cannot take this and plug this into this equation. It doesn't match. I need moles. So we're going old school here. We're going back, way back, chapter 9. Actually, before that, chapter 7, I think. 0.5 grams. I need to take these grams, and I need to convert that into moles. So you set up your little conversion. And what I'm going to do is get this from the periodic table, add up 1 Na and 1 Cl, and that's going to give me 58.5 grams. And remember, that's for 1 mole. It's equivalent to 1 mole. So 0.5 times 1 divided by 58.5 is going to give me 0.008854, and that's moles. Just going to leave that on my calculator and do the next step. So my next step is I'm trying to find molarity. So I need to take my moles and divide by the number of liters that I'm trying to get. So I'm trying to get 0.05 liters. So I'm just going to leave that number on my calculator and go 0.05 liters. I'm going to divide those. In the end, I'll just need one significant digit. And so this is 0.7170, so approximately 2.2 molar. Sorry. So it's a 0.2 molar solution. So not really hard as long as we're watching what units are given and what goes into the molarity equation. Okay. Very simple process. So one type of problem will give you moles in the liters and you find the concentration. Another one, they give you grams. You change your grams to moles and you find your concentration. The third type of problem is going to ask us how to make a solution. How do you make it? Again, it's like Kool-Aid. You measure out your solid and then you add enough water to get the amount desired. So, how would you make a 6 molar concentration of HCl and you want to make 2 liters of solution? How would you make this? Well, as soon as I see this right here, I know that I'm going to have to use the molarity equation. So molarity is equal to moles over liters. I have liters. I have molarity, so that means I'm going to find moles. Because remember, use what you got. Now, so if I stick that in there, 6 is equal to x over 2. So x equals 12. So you're going to have 12 moles. All right, so how do we make this? Well, let's go back in the lab and measure out 12 moles. Oh, wait a minute. We don't have an instrument that measures moles. We need grams. So you must change this into grams if you're going to make it. So how do we do that? Well, conversion factors. Moles on the bottom, grams on top. 1 mole is equivalent to the mass off the periodic table. So you're going to add chlorine, 35.5, plus hydrogen, which is 1, and you're going to get 36.5 grams. All right. So 12 times 36.5 is equal to 438 grams. 438 grams. So how do I make this then? Well, you're going to go back into the lab and you're going to measure out 438 grams of HCl. Put it in the container. And then you're going to add the water. How much water? You're going to add enough water to make 2 liters. Adding just enough to make 2 liters. Now, how do we do this in the chem lab? Well, in the chem lab, we have a nice special glass container called a volumetric flask. Okay. Volumetric flask. It has a really tall, skinny stem, and then a much wider bottom. And it has a special little line on it. So if I fill that, that's the amount that I want. So if this was a 2-liter container, that little line would be the 2-liter mark. Okay. So you would add your solid in here. You'd put that in first. Then you'd fill it about halfway and swirl it until it dissolves. And then you'd fill it up to this line. So if you took a much closer look at this line, when you fill it, the water should go like this. And then you'll have exactly 2 liters. Now remember, you have to add the solid first, because if you fill this to 2 liters first and it looks like this, and then you add the solid, that's going to go up. Okay? So you always put the solid in first. And there you have it. That's how you make a solution.